You kind of describe what it is you do and then who or what it could kind of benefit long term.
Our work is focused on trying to improve the functionality of prosthetic limbs. The thing we want to do is to try and restore their missing sensory feedback from the limb, to see if we can improve things like their balance and gait. Without that sensory feedback, prosthetic limbs are often, they're much more like a tool than a part of the body. We use commercially available FDA cleared spinal cord stimulation electrodes that we implant near the spinal cord, either in the neck or the low back. And then we connect them to an external stimulator. So that's where one of the places that the Ripple device comes into play. And we stimulate and try and see if we can generate sensations that feel like they come from their missing limb, and try and understand how to control those sensations. So can we change how intense they feel? Can we change what, do they feel like a buzzing sensation versus pressure or movement? And then we put sensors on their prosthetic limb, either on the fingertips of the hand or in the sole of the shoe for a lower limb amputation, and use signals from those sensors to control the stimulation. So that, like, if the hand makes contact with an object, we measure the pressure on the fingertips, and then we stimulate in a way that hopefully the person feels pressure in their missing fingers. So it feels like it's coming from the prosthetic limb. Or similarly, if we detect pressure under the sole of the foot, like when the heel contacts the ground, we stimulate so that they feel a sense of pressure in their missing foot, and it feels like it's coming from the prosthetic limb. The goal is to try and make these kinds of systems available to anybody with a missing limb, to try and help them to improve the functionality of the prosthetics. And then the other excuse me, the other piece of it that we focus on quite a bit is phantom limb pain, which is a huge problem for people with amputation. Something like 85% of amputees experience phantom limb pain, and it can be really debilitating. And so there's some evidence that the lack of sensory feedback is part of what at least causes the initial generation of phantom pain. And so we want to see if we start providing meaningful sensory feedback, can we improve that pain?
Gotcha. I know you finished your PhD at Case Western in 2012, and you were working on some different walking type of applications there. How did you initially kind of get involved with developing neuroprosthesis to restore sensory and motor function in patients and neural damage? Was it a class that you took in your undergrad or something you read in popular science? What kind of got you into that area?
So I did my undergrad at Boston University in biomedical engineering, and at least when I was there, I don't know if they still do this, but your senior year, you had to do a full year senior project. Mm-hmm. That was more or less like a job. It was like 30 hours a week for the entire year. And you would pick a lab to work in to do a research project. And so Jim Collins, who is, he's the kind of person who goes into a field and basically completely revolutionizes it, and then he gets bored and then moves on to a different field. He's a MacArthur Genius Fellow. He's this amazing guy. He, at the time, he had a project that was focused on using mechanical vibration at the soles of the feet to improve sensory function and try and improve balance control. Like for people with diabetes, the elderly, basically you would have these insoles you could put in your shoe that has really low level, sub-sensory threshold mechanical vibrations that improve your sensory function. And then they wanted to see if they can make that a useful intervention for people with, sensory impairments.
So like a full open loop kind of system.
Yeah. Okay. All it does, so it's this phenomenon called stochastic resonance, where if you apply sub-threshold noise, you can improve information transfer for things like neurons.
Huh.
Yeah, it's sort of a weird phenomenon, but he taught a class that I really liked, so I reached out to him to see if I could work with him. And so I spent that year working on that project, and it kind of lit the fire for me for, neural engineering. the curriculum at Case Western around neuroprosthetics is amazing. You know, it's heavily focused, or at least at the time, it was heavily focused on stimulation as opposed to recording, but that's the kind of stuff that I was working on. And so, yeah, so, you know, less so, I think now it's probably a little different. They probably have a little bit more like BCI kind of, you know, stuff in their curriculum. But when I was taking these classes, I was getting to basically, I was taught by like the people in the field, you know. Tom Mortimer taught some of our classes, Dominique Duran, Dustin Tyler, like we're getting to learn all these, you know, the details of neural engineering from Bob Kirsch, all these people that were sort of, you know, huge players in the field and really knew their stuff. And so, yeah, I mean, there was one class, it was a, like a bioelectric phenomena. It was basically like a math class that was, you know, focused on understanding the effects of electric fields on neural tissue and that sort of thing. Dominique Duran taught this class, and that one was huge for sort of, you know, really starting to gain that understanding of how neural engineering works and what happens when you apply stimulation currents to neural tissue and all that sort of stuff.
Are there any like developments recently in the field that are really exciting you?
You know, I think all the focus on on things that are not sort of like the traditional points of entry, right? Like, I mean, you know, the way I got into this stuff and the way I think people often do is you think about like restoring function for people with spinal cord injury, restoring, you know, like, so BCI, like all these, like these really high tech approaches. And to be clear, those things are all super cool. I love working on them and I think they're really worthwhile. But, you know, from a practical standpoint, right, the things that are going to have sort of the most immediate and maybe immediately broad effects are things related to, you know, like restoring bladder function, or all the work that's going on right now, like through the Spark program, focused on vagus nerve stimulation and all of these approaches to treating, you know, disorders of the autonomic nervous system and disorders of the internal organs and all of that sort of stuff. I think, you know, they're the things that, like, for somebody who is completely naive to the field, if you ask them like, what is, you know, what's like really important, you know, they're not necessarily the things that they would list first, but I think those are probably the places where we're most likely to have impact
in our
the short term.
Yeah.
You know?
Yeah.
And so, yeah, I think these concepts around like seeing if we can get away from pharmaceuticals and use electrical stimulation or other techniques, you know, optical, ultrasound, whatever, to interface with the nervous system to treat these diseases and disorders that, you know, often really don't have very good treatments. I think it's a really cool area.